First, we're asking calculate the probability of the event E when ns is 12 and ne is 4. That means the sample space has 12 elements and the event E has 4 elements. So the probability is straightforward. You can say probability of the event E is number of elements in the event divided by number of elements in the sample space. So then you get 4 over 12, which is 1/3. That's the probability for first one. Second one, calculate the probability of the complement of the event. So we know that probability of the complement of the event will be 1 minus probability of E. So you have 1 minus 1/3, which is 2/3. We are done. Number 3. Now we want the probability of the event that the number add to 6. So the number add to 6 will be those outcomes you can see here. So starting from this goes like this. So we see here 1, 2, 3, 4, 5 outcomes. So the probability you can say sum equals 6 will be 1, 2, 3, 4, 5. 5 over 36. We are done for number 3. Number 4 says roll 2 distinguishable 6-sided dice. So then we have the same sample space. Find the probability that the event, find the probability of the event that both the numbers are prime. So where do you see our both numbers prime? So first you look at here 2, 2, 2, 3. Then you have, so you can count like this 2, 2, 2, 3, 2, 5. Then you have 3, 2, 3, 3, 3, 5. Then you have 5, 2, 5, 3, 5, 5. Yeah, those are my prime numbers. 2 is a prime number, so 2, 2 is fine. 2, 3 fine. 2, 4 we cannot take. 4 is not a prime number. And if you look at other things here, this is a whole column, not both are prime. 1 is not a prime number. So that's why you are collecting like those. You count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So then probability both prime will be 9 over 36, or you can say 1 over 4. So next we are going to problem number 5 and 6. So problem number 5 says probability of A union B is 0.5, probability A is 0.2. We need to find probability of the event B where A and B are disjoint events, which means their intersection has no element. That means they are disconnected. So then we know one form, straightforward, that probability of two events A union B will be probability A plus probability B minus probability A intersection B. So in this case, if we ignore A intersection B, that's fine because it is 0. Now, if you plug all the values, probability of A union B is 0.5. Probability of A is given is 0.2. And you have a probability B, and then intersection has 0 elements. So then probability of B will be 0.5 minus 0.2, which is 0.3. So we are done for number 5. Next we are going to number 6. In number 6 it says probability distribution. So probability distribution is something like the random variable x has the values like 2, 3, 5, 6, 8, and then probability of those is listed like 0.1, 0.4, then we have a missing here 0.2, 0.1. So usually we know sum of all these should be 1. So if you have this one is missing. For this 5, you can figure out like 1 minus 0.1 plus 0.4 plus 0.2 plus 0.1. So you are getting 1 minus, you can see here, 0.8. So then you get 0.2. So then you can write here 0.2 on the table for 5. So then finally we got like x 2, 3, 5, 6, 8, and the corresponding probabilities we have 0.1, 0.4, 0.2, 0.2, 0.1. Now the average value is simply summation x times px. So that means you say 2 times 0.1 plus 3 times 0.4 plus 5 times 0.2 plus 6 times 0.2 plus 8 times 0.1. Simplify all of this and that will be your answer.